Good afternoon, everyone. Here we are discussing northwest corner rule, which is a solution of a type of initial basic feasible solution or transportation problem. This is my given matrix where destinations are D1, D2, D3 and sources are given O1, O2, O3, O4. So there are 4 rows and 3 columns are there of the matrix. This is AI, supply values, and this is Vj values, which are called demand values. These values are called supply and these values are called demand, and this is my cost matrix. First we have to see the summation of supply value and summation of Vj value is equal to or not. Here these two values are equal, therefore this is called balanced transportation problem, and then there exists a feasible solution to the transportation problem. Now you obtain an initial basic feasible solution as follows. First we have to choose in the cost matrix the most northwest corner position or most northwest corner cell. This cell is most northwest corner. So we are choosing this cell and allocate the minimum of AI and Vj values corresponding row and corresponding column, that is A1 and V1. So minimum of A1 and V1 is 5. So we are allocating 5. Now it will fulfill the corresponding supply once we are shading this row, and this will rest value of the Vj value 7 minus 5 equals to 2. In the next step we are discarding the first row since it will be completed its requirements. Then in this cost matrix we are that this is the most northwest corner cell, and here the minimum of AI Bj is 8 and 2, so minimum is 2 is allocated here, and this is the fulfilling the first column value, and rest value is 6 for this row. So in the next step we are discarding D1 column. This is my next matrix where the most northwest corner cell is this one, where we have to allocate minimum of 6 and 3, that is the minimum of AIBJ is minimum of 6 and 9, where we have to allocate 6, and after 6 allocating it will fulfill the row requirement, so we are shading this cell, and 9 minus 6 equals to 3 is the rest value. So we are discarding this row for the next step. In next step, this is my required matrix where we have to allocate most northwest corner cell. This is the most northwest corner cell where we have to allocate minimum of 3 and 7. This is the minimum of AIBJ value. So the 3 will be allocated. So it will complete the requirement of this one, demand requirement or demand of this column. So is shading this column, and rest value of this supply is 7 minus 3 equals to 4. So in the next step we should discard this column, so we have the rest of the matrix in this form, where also we have to allocate minimum of 18 and 4, so 4 will be allocated, and this will complete the requirement of this row, and the rest column requirement is 18 minus 4 equals to 14. So after that we have the only this matrix where the AI and Bj value are same. Normally this is in fact that at the last cell we are allocating the values of AI Bj always is, it will be the same value. So it will gives us the security for the allocation. So after that this is my final allocation which we have shown in a matrix, and these are the allocation values in which cell these are allocated. This is the total cost formula where we are putting the cost value and corresponding allocated value, and this is my final result of the required minimum cost of transportation. Again I am telling you that this question also can be solved by only in one matrix. This is my required matrix where we are choosing northwest corner cell and allocating minimum of AIBJ 5 and 7, 5. So 5 is completed the requirement of this row. We are shading this two cell, and rest value is 7 minus 5 equals to 2. So next matrix is this one where this is the most northwest corner cell where we are allocating minimum of 8 and 2, that is up 2. So this will complete the column requirement. So we are shading this where further allocation will not be possible, and rest value is 6. Next matrix is this one where this is the most northwest corner cell where we are allocating minimum of 6 and 9, where the 6 is minimum and which will complete the requirement of this row. So we are shading this cell, and the value of the rest is 9 minus 6 equals to 3. And the next matrix, required matrix, is this one, where we have to most northwest corner cell is this one, where we are allocating minimum of 3 and 7, where the minimum value is 3. So requirement of this column is completed. We are shading this one, this cell, and last rest value is 7 minus 3 equals to 4. So next matrix is this one, where this is the northwest corner cell, where we are allocating minimum of 4 and 18, that is a 4. So requirement of this row is completed, and rest value of this column is 14, and last cell is 2, where the minimum row and column value is same. So this is equal to 14. So this can be calculated in only one matrix also. This is the allocation, and this is the total cost, and which is not optimal. This is the only initial basic feasibility.